Good morning. Today we are going to see how to write a recursive program for finding the factorial of a number. So as all of you know that recursion is nothing but a function calling itself. Now we are declaring a prototype like a long fact integer n, which indicates that fact is the name of the function. It takes one integer argument and it returns a long integer result. Here long integer is result is required because the factorial of a number is very large. So in the main function I have declared one integer variable n and one long integer variable result. I am reading the value of n, which is a number for which I have to find the factorial by scanf %d %n. I am calling the factorial function by passing n as an argument. And the factorial function returns the result which will be stored in the res variable. Now I am printing the factorial of n is result. And in the recursive factorial function, it takes one integer variable which is here x, which is a formal argument. So I am checking if x is equal to 1 or x is equal to 0. If either x is 0 or x is 1, the result is 1. So I am returning 1. Otherwise, the factorial of x is x into factorial of x minus 1. Since you can observe here, the factorial function is calling the factorial again inside its body. So we say that it is a recursive function. So this is the body of the fact function. Now let us run it and check for a few inputs. Now if the value of n is 5, you can observe that the factorial is 120. Suppose if I give the value of n is 1, you can observe that the factorial of 1 is 1. Now we'll see the second program, which is to find the GCD and LCM recursively. So again here you can observe that GCD is a function which takes two arguments and it returns an integer result. And LCM is also a function which takes two arguments which are integers and returns an integer result. Now in the main program I have declared the variables a and b for which I have to compute the GCD and LCM, and the result 1 and result 2 will hold the results of GCD and LCM. So I am reading two numbers by using scanf %b, %d, %a and %b. And I am calling the GCD function by passing a and b as the arguments. So now GCD function, it returns a integer value which will be stored in the result 1. And I am printing the value of GCD of AB is result 1. Again, I am calling the LCM function by passing a and b as argument and storing the result into res2 and printing the LCM of AB as result 2. Now we'll see how to write the recursive GCD and LCM function. So in the GCD function, I have x and y as the formal arguments. And here the logic here is, if y is 0, then x will be my GCD, which is written by return x. Otherwise, I am going to return the GCD of y and the x mod y. So this will happen until y becomes 0, at which point the x will be the GCD. This is the recursive GCD function. Now we'll see the recursive LCM function. Here I have made use of a static integer t and I have initialized this t is equal to 1. Now the condition to be tested here is, if t mod x is equal to 0 and t mod y is equal to 0, then return t. Otherwise you increment t and return the LCM of x comma y. Here the static integer t will be the variable which will be incremented each time if either t mod x is not 0 or t mod y not equal to 0. So if this condition, either t mod x is equal to 1 or t mod x is equal to 1, any one, if it is not equal to 0, then t will be incremented because least common multiple. So first we will check whether 1 is the LCM. If not, we increment t to 2. Then check whether 2 is the multiple of both. Then until there is a common multiple of x and y. This is the logic of recursive LCM. Now we will run this code and check the output. The first case we will see is where both the numbers are having some common factors. Suppose I give the numbers as 12 and 4. Now you can observe that the GCD of 12 and 4 is 4 and the LCM of 12 and 4 is 12. Now we will take the two numbers where there is no common factors, 2 and 9. Now you can observe the GCD of 2 and 9 is 1 and the LCM of 2 and 9 is 18.